This question is about the properties and reactions of ethanoic acid, CH3COOH. Ethanoic acid is a weak acid with an acid dissociation constant Ka of 1.75 times 10 to the negative 3 moles per decimeter cubed at 25 degrees Celsius. Part A. A student uses a pH meter to measure the pH of a solution of CH3COOH at 25 degrees Celsius. The measured pH is 2.440. Calculate the concentration of ethanoic acid in the solution. Give your answer to 3 significant figures. Let's begin by highlighting the key pieces of information in this question. First key piece of information is the acid dissociation constant, or Ka value. Also focusing on the units. The second key piece of information is the measured pH of 2.440, and the fact we need to give our answer to 3 significant figures. Firstly, we can use the equation of the concentration of H plus equals 10 to the negative pH. So if we apply this equation, we would write that the concentration of H plus ions is 10 to the negative 2.44, which gives us a value of 3.63 times 10 to the negative 3 moles per decimeter cubed, because the square brackets means concentration. Then applying the Ka equation, which is Ka equals H plus squared over the concentration of ethanoic acid, or CH3COOH. If we rearrange this, we would get the concentration of CH3COOH equals the concentration of H plus squared over Ka. If we plug in the numbers, that would be 3.63 times 10 to the negative 3 squared over 1.75 times 10 to the negative 5. That gives us a value of 0.753 moles per decimeter cubed if we write our answer to 3 significant figures, which is what we're asked to do in the question. Therefore, on the answer line, we need to write 0.753 for our answer for moles per decimeter cubed. To get the 3 marks in this question, you get a mark for working out the H plus ion concentration, a mark for writing or working out the concentration and rearranging the equation of CH3COOH to give you the value of 0.753. So to clarify, that's a mark for rearranging the equation and a mark for your answer for this question. Part B. Ethanoic acid is added to another weak acid, fluoroethanoic acid, FCH2COOH. The Ka value of fluoroethanoic acid is 2.19 times 10 to the negative 3 moles per decimeter cubed. An equilibrium is set up containing 2 acid-base pairs. Complete the equilibrium and label the conjugate acid-base pairs as A1B2 and A2B2. So if we look at the Ka value of fluoroethanoic acid, it is a bigger value. Therefore, fluoroethanoic acid is a stronger acid. So we can label it A1 and then B2 for our acid-base pairs. In the next part of the equilibrium, that would mean that CH3COOH2 plus is formed, because if ethanoic acid is acting like a base, it's going to accept protons. Then the acid, or the stronger acid, fluoroethanoic acid, would turn into FCH3COO minus, because it has donated its protons to ethanoic acid. If we finish off by writing our acid-base pairs, that would be A2 and B1. To get the 2 marks for this question, you need to have the correct equilibrium. That gets you 1 mark, and then the correct acid-base pairs gets you your 2nd mark. Part C. The student plans to prepare a buffer solution that has a pH of 4.50. The buffer solution will contain ethanoic acid, CH3COOH, and sodium ethanoate, CH3COONA. The student plans to add 9.08 grams of CH3COONA to 250 centimeters cubed of 0.8 moles per decimeter cubed CH3COOH. The student assumes that the volume of the solution does not change. Part 1. Show by calculation whether or not the student's experimental method would produce the required pH. Show all your working. So if I highlight the key pieces of information we need to pay attention to, they would be that the pH we are trying to make is 4.50. We're using 9.08 grams of CH3COONA, and it's 250 centimeters cubed of 0.8 moles per decimeter cubed CH3COOH. If we write down the equation that links Ka and concentrations, that would be Ka equals the concentration of CH3COO minus, or the salt, in this case it would be Na instead of the minus, and then H plus over ethanoic acid, CH3COOH. So firstly we need to work out the number of moles of CH3COONA, or sodium ethanoate. And we do this by taking the mass, 9.08, and dividing this by the relative formula mass of this salt, which would be 12 times 2 plus 3 plus 16 times 2 plus 23. That gives us a molar value of 0.111 moles. Then we can work out the concentration which we need in our equation, because it's square brackets in our equation, which means concentration. So if we take 0.111 moles and multiply this by the volume, so 250 times 10 to the negative 3, because we want decimeters cubed, that gives us 0.443 moles per decimeter cubed. Then, plugging in values to our equation, we would have 1.75 times 10 to the negative 5 multiplied by 0.8 divided by 0.443. We've got our 0.8 moles per decimeter cubed from the question. And we've rearranged the equation so that we're going to find our H plus concentration. And our answer is 3.16 times 10 to the negative 5 moles per decimeter cubed. Then a second equation comes into play, and that is negative log 10 of the H plus concentration equals pH. So if we use this equation, we'd write negative log 10, and then in square brackets 3.16 times 10 to the negative 5. That gives us a pH of 4.50, which matches the one in the question we are asked to find. For this question, to get the 5 marks, you get a mark for working out the moles of sodium ethanoate, a mark for working out its concentration, you get 2 marks for working out the concentration of H plus ions, and then you get a mark for working out pH correctly. Part 2. When the student prepares the buffer solution, the volume of solution increases slightly. Suggest whether the pH of the buffer solution would be the same, greater than, or less than your calculated value in C Part 1. Explain your reasoning. The answer they're looking for in this question is for you to say that it's the same pH or a constant pH, and the reason is it's the same ratio of HA in square brackets to A minus, also in square brackets. So there are 2 marking points for this part of the question. Your first marking point is for saying it's the same pH, and your second marking point is for saying the same ratio of HA to A minus.